we see that between clock time 6 seconds and clock time 8 seconds, the velocity is going to increase from some value here to some value here. We can determine the velocities at this point and this point fairly easily. Remember that for every 2-second interval our velocity is going to increase by 0.8 meters per second. We start at 2 meters per second. 2 seconds later we'll be going 2.8. 2 seconds later another 0.8 gives us 3.6, and then 4.4, 5.2, and finally 6.0. So that the two velocities that we're interested in are 4.4 meters per second and 5.2 meters per second. That's between clock time 6 seconds and 8 seconds. In order to find the distance, or the displacement, we need to multiply average velocity by the time interval. Well, the average of these two velocities, since the velocities are represented by the altitudes or the heights of this graph here, are going to be the same as the average altitude of the graph, the average of the 4.4 meters per second and the 5.2 meters per second. And the average is clearly half of the sum, which gives us 4.8 meters per second. And we can just see that halfway between 4.4 meters per second and 5.2 meters per second is 4.8 meters per second. When we multiply that average velocity of 4.8 meters per second by the time interval, which is 2 seconds, we're going to get the total distance, which is 9.6 meters. And what we've done in the process is we've simply multiplied the average altitude of this trapezoid by its width, the 4.8 meter per second average altitude by the 2-second width, and we've obtained the 9.6 meter displacement. And that displacement, again, is identical and corresponds to the area under that part of the graph.